Hey everyone, welcome back to my channel. This is 𝗕𝗹𝗀𝗀𝗧𝗶𝗱, an AWS community builder and DevOps content creator. In today's video, we are going to deploy a real-world 3-tier application on AWS EKS using Terraform. You heard it right, from provisioning the infrastructure to deploying front-end, back-end and MongoDB, all automated with infrastructure as code. So here what we'll cover in this video. We'll start by creating a Ubuntu instance that will act as our host machine. We'll provision infrastructure using Terraform. We'll set up EKS, ECR and the required IAM roles. We'll push our Docker image for front-end and back-end to the public ECR repository. We'll deploy the services to Kubernetes with 𝗘𝗹𝘀𝗀𝗃. We'll expose the application via application 𝗧𝗵𝗿𝗍𝒻𝒃 Ingress controller, and finally, we'll learn how to clean up everything safely. So before we start the project, let me just go you through the prerequisite. You'll need an AWS account with Docker and Terraform installed, and I will list down the step for it. And you need to install AWS CLI configured with an IAM User. Along with, you need to have kubectl, ekctl and helm installed. So don't worry, this blog I have linked down below in the description box contain all the commands written out clearly. So I will be referring to this blog later in the video. So let's start the project. Let me go to my EC2 dashboard, and here I'll click on launch instance. Give it a name here. We'll select Ubuntu as an AMI, and in the instance type we'll select T2 small and give it a login pair. Let me select an existing group, by default one, and in storage we'll give 16 GB so that everything works fine. Now let's just launch the instance. Okay. So let's wait for it. So now it is in running state. Let's click on the instance, hit connect, copy this sh command, paste it in the terminal. Why does it refuse? Yes. So now we are inside the container. So let's just quickly update everything. Now we'll run apt install docker.io. This will install Docker. Now, to provision our infrastructure using Terraform, we need to provide AWS credential. So let's go to IAM dashboard, and here we'll create a new user and generate the access key and the secret access key for it. So let's create one, give it a name, my user. Next, here we need will attach policy directly, and I'm going to provide administrative access. So this is only for learning and experimentation purpose. In production, it is not advised to give administrative access to any person. Okay, so let's create the user. We'll click on our user, go to the security credential, and here we'll scroll down, and here we have our access key. Let's click on create access key. We are going to use it for command line interface. Yeah, and we'll understand the terms and condition. Click on next. You can give a description tag value, or you can leave it as blank. Let's create it. Here we have the access key and the secret access key. So before putting it, we need to install AWS CLI. So let's go to our blog. Here if we scroll down, you can see the command for install AWS CLI for Ubuntu. So let's copy it, and here we'll paste it. So we don't have unzip, so let's install it first. So let's install unzip. So AWS is configured, so let's use AWS configure. Here will be set access key, secret access key, default region is US East 1. I'm just habit of putting this region only. Output is JSON. Okay, so our AWS CLI is configured. To check it, you can use AWS S3 LS. It will list down all the S3 bucket you have. So I have only this 𝗕𝗹𝘀𝗀𝗏 bucket 1, 2, 3. Okay. So after that, we'll just go to our blog and see what we'll do next. So next we'll install Terraform. So just copy these two commands and paste it here. So the code for our application is available on this GitHub repo. We'll copy the HTTP endpoints of it, and here we'll use git log. Paste it here. Okay, let's get inside it. Okay, so it has all the configuration, backend, frontend, and the Kubernetes manifest. So before deploying the Terra config, we need to create an S3 bucket, because that will act as a backend for our Terraform state file. It is better to have our Terraform state file on a remote location, so we are using S3 for that. So let's create the bucket. So use this command. So this will create the bucket, and we need to enable versioning to maintain the state history. So we'll enable that, and at last we'll have a default inscription, which is AES256. Let's copy this command and just, so our backend is all set up. Okay, so let's go inside the Terraform config directory and list down the content. So here we have our backend.tf file. It basically contains the backend for our Terraform file, which is reflecting to this 𝗕𝗹𝘀𝗀𝗏 state bucket. So you can change the name if the name already exists. Like I created this bucket and it gave no error, so I just kept this name. And let's just see. Let's initialize Terraform. So our Terraform is initialized. Let's see what are the resources it plans on creating. Use Terraform plan for that. This way it will tell you like 11 resources are needed to be added in this. So let's check it one by one. So first we are creating an ECR public repository named backend. Like the repository name is 3-tier backend, and another one is 3-tier frontend. Then we are going to create an EKS cluster which will be named as 3-tier cloud. And in the VPC config we are selecting the default VPC, which contains 3 subnets which are all public as listed below. So down we have the EKS node group. It contains all the node configuration. So here we don't have an instance type here, but I have actually supplied it in forms of launch template. So I selected t2.medium for our node. So we gave the node group name as EKS node group, and it has all the 3 subnet. And here is the launch template. So we have provided the latest version we have the desired size as 1, so there will be only one node apart from our host machine. And here we have the rules that are needed for EKS cluster and node group to work properly with other services. So we have STS, assume role and tag session for EKS. Along with that, we are adding some additional policy like EKS worker node. I will list down below. Okay, so here is the node group. Okay, it also has some permission, and these are the permissions that are needed to be added for the EKS cluster role. So like Amazon EKS cluster policy, these are the policies that you have to manually add to the role while dealing with it from the console, but using Terraform we can just supply it as arguments. So here is the launch template. Here we have specified that our instance type is t2.medium, and note down this, the HTTP put resource off limit to 2. If we don't specify the launch template, it will by default set it as 1. Then it will cause issue with Ingress, like the Ingress resource will not be set up just because of this. So I need to add the launch template just to fix this error. Okay, so now let's apply the configuration using Terraform apply command. So this will take about 15 to 20 minutes because EKS cluster and node group takes time to provision. So I'll get back to you when it's done. You just need to provide yes here, and it will start creating the resources. So you know the backend and the front-end repository are created within 0 seconds. So let's just wait for EKS cluster and node group to provision. After like 9 minutes, our infrastructure is provisioned successfully. So let's go to our eShare console and see for ourselves that the repository are created or not. So here let's go to repository. So here we have our 2 repository. Let's go into the backend repository. Click on view push command. So here we have our commands. So we need to run it one by one in the backend directory of our project. So let's copy it. Here let's go back inside backend, paste it. First it will log in a user. So login is successful. So let's build the image. Our image is built successfully. Let's tag it. Tag is done. Now we just need to push it to the ECR repository. Okay, so we'll do this thing similar with the front end. So let's go to our front end repository. Click on view push command. We have already logged in, so we're just going to build a treat here application. Let's go back into the front end. Here will so our image is built successfully. So let's just tag it. Now we just need to push it to our directory. So once the push is done, we are just gonna update it into our Kubernetes manifest. So let's wait for it. Okay, now let's go to our Kubernetes folder. Here we need to change something like the front end deployment YAML. Here you need to change this thing. It is a unique address which is specific to every individual. You need to change it. You can find it here. Like if I refresh it, here you can see that this is the unique code. So you copy it and paste it here. Similarly, you need to change it for backend deployment. So you can see that I have already done it because it is my account. So while writing with log, I have already done that. So now we just need to apply this manifest to our Kubernetes cluster. So to do that, first we need to install kubectl. So let's do that. So this is the command. We'll copy it. So now our kubectl is installed. Similarly, we'll install AKctl, which we'll need at later point of time. We'll just install it now. So AKctl is also installed. So now we need to update the kubeconfig to tell kubectl to use our 3-tier cloud EKS cluster as it. So here is the command. Just copy it. This will update the kubeconfig. So if we use kubectl get nodes, you will see our single node here. So you can see that we have our single node which was created 13 minutes ago. Okay. So now let's apply our file one by one. And front-end deployment, then front-end service. I did forget to provide -f here. Have to do that. So okay, there's one thing we're missing here. We need to create the namespace workshop because every architecture, every resources we're creating in Kubernetes is under workshop namespace. So I have the command for it. Let me just go down here. Where was it? Is here. There they are. Use these two commands. It will first create a namespace and then set the workshop namespace as our default namespace. Okay, so our namespace is created. Now we'll just apply the files. Similarly, we'll apply the backend file. So we have our 2-tier up. Now we just need to install Mongo. Here just run kubectl apply -f dot. It has all the secrets, deployment and service. Okay, so now we'll just see how our pods are doing. So our pods are up and running. Let's see. So you can see that our pods are up and running. So now we'll set up our application load balancer for Ingress. So for that I have already listed the IAM policy here. Let me just go back. So this JSON create all the permission required for EKS and the node group to communicate with other services. Like I downloaded it from the AWS GitHub page, but it lacks some permission. I think it is because of my own requirements. So I just added 2 permission here, which is EC2 describe route tables and EC2 elastic load balancing describe this here. So these 2 permissions were lacking. That was causing much error. So I did it manually, and so that you don't get this error, I just put this file in the GitHub repo. Okay. So now let's create an IAM policy with this named AWS Load Balancer Control IAM policy. So just paste this command here. I already have this policy created, so I don't need to create it again. So next we are going to create now we are going to associate the OIDC provider. We are doing this so that we don't run into some authentication error. So let's go with these 2 commands and paste it here. Okay. So now So now we need to create the service account for our load balancer. You copy this command. Here you need to change the account number here. Let me just show you. This is the place where you need to change things. So I'll tell you where to find it. So in your AWS console, go to your user. Here you have your account ID. Just copy it, paste it there. Just go. Okay. So after that, we're just going to install Helm and deploy our load balancer controller. So use sudo install Helm. Then we're going to add the EKS chart repo. Use these two commands and just copy this command to install the AWS load balancer controller. Okay, so moment of truth. Actually, I used to get error at this stage. And voila, our pods are up and running. Now we just need to apply the full stack load balancer YAML file. Okay, so let's see Ingress and workshop. So here we have the address for our application. If we go to this URL, we'll see our application running. So it may take some time. So let's give it 2-3 minutes because it takes time for the load balancer to provision. So here you can see that we have our load balancer. It is in provisioning state. So once it is up and running, you can see our application. So you can see that our load balancer state is active now. Now if we go to the DNS, you can see our application running here. You can see that. So this marks the end of the project. So before closing, we're going to tear down resources easily. So firstly, we'll go to our ECR repo. And here, we'll just delete this image tag. Okay, and after deleting it, we just need to go to our Terraconfig directory, and here we need to run Terraform destroy. It will peacefully and easily delete all the resources. You don't have to do anything. So it will ask you to delete 11 resources. Just say yes. So as the destruction is in process, we just need to go to our EC2, and here on the load balancer, you need to specifically delete it because sometimes it's just failed to be deleted. Now our resources are completely destroyed. Now we need to just delete the Terraform state file from the S3 bucket. So use this command for that. This will remove the file, and now you need to go to your S3 console to delete the bucket willingly because we have some labeling and server-side encryption, so we can't delete it pragmatically. So let's select it. So empty the bucket. Once the bucket is empty, you can delete it. Okay, so the bucket is deleted successfully. Now let's delete the host machine on which we are working. So click on it, insert it, done. And that's a wrap up for our full deployment of a 3-tier application on AWS EKS using Terraform. This project is part of my journey to become Terraform ambassador, and I hope it helps you learn how powerful infrastructure as code can be. So the blog link and the GitHub repo are in the description. If you found this useful, drop a like, subscribe for more DevOps content, and share it with someone learning Terraform. Thanks for watching. See you in the next one.